EMCEI spatial-temporal distribution of atmospheric pollution modeling using interpolation technique for Tampico metropolitan area. This work is for different schools. The first one is the professor Doctorado by Instituto Tecnológico de Altamira, Engineer Maite Guadalupe Castillo by CICATA Altamira, Alejandro Caballero Col by Universidad Politécnica de Yucatán, Professor Dr. Felipe Caballero Briones by Instituto Politécnico Nacional CICATA Altamira, and MIA Mireya Ovando by Universidad Tecnológica de Altamira and CICATA Altamira. Can I take it?
Sure.
This project is located in Mexico, that is around 1,125 kilometers from Morocco, and in the state of Tamaulipas, that is at northeast of the Mexico near to the USA, and in this state, the study area, the Tampico metropolitan area, represents around the 2% of the whole territory in Tamaulipas. In this state, in order to know the geography, you can find that there is a northeast, you can find two cities, Aldama and Gonzales, and east, Gulf of Mexico, and sur, the Pánuco River, and north and southeast, two lagoons, Champayan and Chaguey Lagoon. These represent the 90% of Altamira, 3% of Madero, and 7% of Tampico, of the study area. It's an important city for all the activities that are in here, the economic activities. At north, you can find in this part different companies, in this case that are called industrial park. In the middle, you can find an international airport. At east is an oil industry, Pemex. And another important activity that we have is the bridge. That is important for us because join to another state, that is Veracruz, and bring a lot of different tourists in vacation time. If we talk about the parameters, the meteorological parameters, we can find in winter north and northwest winds, at spring and summer sur and southeast winds, and the rest of the year east, west, and east land breeze. It's important for us because we need to identify the variation or the spatial distribution of the pollution. In this case, of objective of this work is to obtain a spatial-temporal distribution of particulate matter, in this case only 2.5, because it's a high impact by the size of it. In different seasons, in this case 3 seasons. October, that represent fall, January, that represent winter, and April, that represent spring. And another important thing that we need to do is a triangular irregular network in order to interpolate a technique to create a statistical analysis and then control the result with the limits that we have in Mexico and international guidelines. In this presentation, I want to talk about the methodology, the equipment that we use, the interpolation technique, the maps, and the results. If we talk about the methodology, we divide in 4 different parts. The first one, the data preprocessing, the modeling, the spatial interpolation technique, and the maps and results. If we talk about the data preprocessing, first of all, we monitor the particular matter. Then, with 2 different devices, we collect the information and condition the data. Then we use a modeling. With all the information, we create a file and characterize the different techniques and use a head map in a platform that is called QGIS. In these QGIS, we have different tools in order to do a methodology to interpolate and create at the end a maps. If we talk about the equipment, we have 2 different devices. The first one is the air quality station that is from Spain and can monitor different gases and particulate matters, and can monitor meteorological parameters too. However, we use another device that is called META, that is from USA, and can measure wind direction and speed relationship. Both of them have a cloud in that we upload the information, we download the information, and then conditional with a Python, that is another program in order to identify and create this file. With all this information, we upload the document in a QGIS that I told you is a program, and characterize the different techniques that we need, or the different characteristics. For example, define the spatial grid. In this case, we we use 5 times 5 kilometers a lead. We create a hot map. This is a technique that represents the density around the pollution and use a time polygon that is triangular, irregular network. We have 3 different points that are measured and known, and if we didn't know another one, like in this part, we create another with the interpolation technique. This is the idea of the triangular polygon. And then create a map. You can upload different techniques or different information to the map. In this case, we add the fixed emission source, small, medium, and large. You can find different colors because it's the air quality index. In that, good is going to be blue, green is going to be reasonable good, until purple that is extremely good, extremely unfavorable. And it's going to be the same with the graphic that you can see. In this case, I represent the October season, that's the October month that represents the fall season, and the 70% we have a good quality. The 25% we have a reasonable good. But this was changed in another month, of course in another season. In this case, in winter, in January 2024, we can see different colors that represent the quality was different too. You can find the green one that is unreasonable good, the yellow that is regular air quality, and the red one that represents unfavorable good condition. By the other hand, in spring, that is the last month, April, we identify 3 colors too. The blue one, that is a good, the green one, that is a reasonable good, but the yellow one is the same with irregular conditions. With all this information, the idea is that we are going to continue working with the other season, summer, because it's going to be the next month, and we are going to try to identify the same characteristics and how is the influence with the speed and wind condition and direction of the wind in order to strong influence that we have in the area. Of course, this is our first study. We start in October, so we need to continue to study and change or consider another parameters like foggy, pressure, logs, and orography in order to be better at this project and know the other pollution that we have and the other gases that we can check into. And it's very important for us to continue with this work because we don't have any kind of information about air quality. It's important for us in order to know how it's going to affect the public health and consider some emissions that are going to be bad for us. Thank you so much.